Alright, so we are team going bananas because you are going to be going bananas after you see our project here. It's done by Cory Diehl, Edward Miltimore, Haley Lawrence, and Matt Detmers. You're all in the room. We're all doing this project together. It's been a really long semester. So, let's see here. There we go. So the goal of our project was to make a home experience easier. Studying at home sucks. I'm sure many of you can relate to that. The Google Voice API allows us to search for information on and helpful tips on the internet. While using its voice to text feature, we can control various applications. If it's too hot, turn on the fan. Forgot to turn something off. No worries, the device knows when you've left the room and aren't there anymore. And if you need some sweet study music, just ask for your favorite station on the radio and it will turn it on. We'll see all this later. So, the part that I did in the project was I set up the Google Home API and got it doing the speech to text recognition. And then I took the Node MCU, which is a great microcontroller. It's got an ESP8266 on it, and that is what allows us to connect to the internet.
Remote blue light on.
Turning the blue light on wirelessly.
Okay, Google. Remote green light on.
Turning the green light on wirelessly.
Okay, Google. Turn mood light on.
Turning rainbow effects on.
Okay, Google. Play music.
Playing your jam.
Okay, Google. What is physics about?
According to Wikipedia, physics is the natural science that studies matter and its motion and behavior through space and time, and that study...
I'm Miltimore, and for my 174 part of the project, I connected an ultrasonic sensor and a servo motor to an Arduino Nano to read in serial data. It was going to take distance and a degree angle and 180 degrees swing to take data from the room. I read in that data via serial port from the Arduino to the Raspberry Pi, and then I plotted the distance versus the degrees using Matplotlib, and then we're still working on wirelessly controlling the module with Google Voice. We're running into library issues, but we'll try to get that done. Alright, so when we start the Arduino code, the servo is going to sweep back and forth, and the ultrasonic sensor is going to continuously read in data, and then we're going to take that data and throw it through the serial port and then plot it. And then also, so this is the data that we're reading in here. We have 180 points of data that we're going to read in, and then this is the code that we read in the data from via the serial port. This is the data, or this is the code to plot said data, and then this is the plot itself.
Hello, my name is Matthew Detmers, and for my 174 project, I integrated a Raspberry Pi with a smart home integration, so a software-defined radio combined with AI in the future. So the first thing my Pi is doing is it's a hotspot, providing connectivity for the rest of the Pis around the room and other IoT devices. The next thing it's doing is it's an RTL SDR receiver using the RTL SDR library piped into a Python wrapper. The next thing it's an Arduino connected to the Raspberry Pi that's also connected to a GPS receiver. That GPS receiver is used to pull in a 1 second per second pulse that is then parsed out into real-time clock that is actually ridiculously accurate as it uses the cesium atomic clocks located in space. The last thing is the Python wrapper for the RTL SDR hooks into it has a REST API listener, which allows it to integrate seamlessly with Cory's Google Home. Alright, and if you have a moment, we can step over to the demo. Alright, so on the right hand side here we have our server console that is hosted on our Raspberry Pi. This just shows the status of the server and any requests it will be receiving at any point in the future. On the left hand side we have our server, I guess this would be our client view. Here you can see the current frequency it's tuned to. You can change the frequency in the text box. You can change modulation, as well as see the time that is imported through a serial port on the Raspberry Pi and Arduino. Alright, so on the left hand side we have our setup here. I'm just going to turn the stereo on and change the frequency. So let's listen to a local radio station, 88.9, and change the gain up to full. And we should hear some classical music in there, but I guess it's too weak. Alright, and that's how the Raspberry Pi STR package works. You've got your clock and you've got your server status and your radio. We're good to go. For the last part, the integration with Cory's smart home, you can say, "Okay Google, turn on the radio." And on the server, it will change the it's not working right now. It changed the radio station that is available on the radio itself to 102.5. So it's tunable from the Raspberry or the Google Home.
So my name is Haley Lawrence, and for my part of the 174 final project, I went ahead and connected a Node MCU to Cory's Raspberry Pi. I used an IP address and a MQTT code on Arduino IDE to go ahead and use Wi-Fi to connect the two. Along with that, I attached a motion sensor as well as a temperature sensor to interact as well. With the motion sensor, I have on the serial monitor a 0 or 1 to display if there's motion or not motion, just so that I can check that it's interacting with this or working properly. And then on the Raspberry Pi Python screens, if there is motion, it'll say motion detected. If there is not, there will say no motion detected. Along with that, the other sensor I use is the temperature sensor. With the temperature sensor, it's going to go ahead and read the temperature of the room. Most of the time it's been in between 70 and 80 degrees. And with that, we went ahead and I put in the code that if the temperature is over 70 degrees, that it will go ahead and switch on the fan that is linked also onto the main Python code for the Raspberry Pi. So with that, okay Google, check for motion.
Checking for motion.
So this is without motion. Now, okay, so now with the temperature, I'll go ahead and interact it with Google Home. Okay Google, apartment temperature.
The temperature of the apartment is too hot.